So today we're going to jump to section 5.6, which is inequalities in a triangle. We combine this in our chapter 4 topic because of the triangle aspect. There are 3 major topics that we're going to cover today, and the SOL loves all 3 of these topics. So here's the first one. It talks about where the longest side is in relation to the largest angle. So if you have the longest side is always directly across from the largest angle. So, and it's the same thing with the smallest side or the shortest side. Oh, it's over there, sorry. The shortest side is always across from the smallest angle. Okay, so we're going to go through a couple examples just to highlight this topic. And the first one is talking about naming the smallest and largest angles of the triangle. And we don't know anything about the angles or degrees, but we do know the sides. So if we want the smallest angle, we have to locate the shortest side, which would be side AB because 6 is the smallest side length. Well, the angle across from that is angle C. So angle C is going to be our smallest angle. If we want to locate the largest angle, we got to find the longest side, which is side AC, represented by the length of 18. So the angle across from that would be angle B. So angle C is the smallest and angle B is the largest angle within that triangle. So go ahead and try to do the second one on your own. Hopefully you find that angle, and that is an R, it kind of got cut out. Angle R is the smallest and angle Q is the largest. Okay, just look for the wording because sometimes it'll flip it and say name the angles from largest to smallest, so make sure you're just reading. The next one talks about naming the shortest and longest sides of the triangle. So we can do the same thing. If we want the shortest side, we've got to find the smallest angle, which would be angle S. The side across from that, side RT, will be the shortest side. Let's take a look at the longest side. Well, if we want the longest, we have to find the biggest angle, which is angle R. The side across from that, ST, will be the longest side. So there is the shortest and the longest sides. All right, can you do the second one on your own and find the shortest and longest sides?
Well, hopefully you guys realize that we're missing the third angle. So we've got to actually do some calculations to figure this out, okay? So this should be 55 degrees, all right? We knew 35, we knew 90, subtract that from 180, and we get 55 degrees. And now you should be able to figure out your shortest and longest sides. Well, my smallest angle is 35, so that's angle H. Across from that is side KJ. My longest side, you should have figured out, is across from my 90-degree angles, also known as our hypotenuse, right? Which is HJ. All right, so this one, you've got to actually do a little bit more algebra, but go ahead and figure it on your own and see if you can figure out which side belongs in each of these boxes, the shortest, the medium, and the longest. And we'll drag ours up and show you our answers in just a second. Okay, so you should have done your work. We found out that doing our algebra, X is 38. Plug it back in, and we figure out that we've got our angles of 38 for angle A and 66 for angle B. So our shortest side, notice we've got all 3 of them this time. Our shortest side is BC. Our medium side, or the side in the middle, we can do last. Let's do our longest side first because that one just stands out a little bit more. And that's going to be opposite of angle C, or side AB, leaving us AC to put in the middle.
And that's a great SOL question that we see all the time. All right, our second topic, it talks about, can you create a triangle, or does a triangle really exist? Well, yeah, a triangle exists, but not with all the time the numbers sometimes don't work out. So here is the way that you can prove if something is a triangle. This is the way it states that in any triangle, any 2 sides must sum to larger than the third. But if you kind of read the next part, it might help you. The sum of the 2 smallest. So you find the 2 smallest numbers, and it has to be larger or greater than the third. And since we're talking about sum, we're talking about adding. Now, not all 3 combination numbers always work. So for instance, I'm going to talk about, well, what if you add up the 2 smallest and they equal the third side? Well, think about this. Here's the third side. If you have 2 that add up and they're equal, what's going to happen is they're going to fall flat and create this straight line because there's nothing holding it up and being stable. So if it's equal, it's a straight line. What if it is less than? What if you add up the two smallest and it's less than? So you have the largest side, the longest, and if you add them up and it's less than, well, you get this, I just say a gap, because they're never going to meet. You have this gap in the middle, and they can't reach each other. So that's why it has to be larger or greater than the third. So let's take a look at these three. Okay, the first one is the combination of 7, 1, and 5. So the two smallest, 1 plus 5, needs to be greater than the third. So 1 plus 5 is 6. Is 6 greater than 7? No. So at this point, we know that this cannot form a triangle. This actually would give you the gap. Okay, it wouldn't work out. So second one, 1 plus 1, the two smallest, greater than the third, 2. So is 2 greater than 2? No. So this is the one where it would form a straight line. And lastly, the third, 8 plus 2 greater than 9, 10 greater than 9. Yes, so this does form a triangle. So that's our second topic.
All right, since we know that the two smallest sides have to add up to be larger than the third, what if I only give you two sides? Let's come up with a possible range of values for that third side. So we're going to assume that this 12 in the first one could either be one of the smaller sides or it is the biggest. So in doing that, we're going to do two answers. My answer is always going to look like my smallest number is less than x, which we're going to call our third side, which is less than my larger number. All right, so this is how you give a range of values or the possible lengths of the third side of the triangle. All right, so 12 and 6. I'm going to do subtraction, and then I'm going to do addition. 12 minus 6 is less than my third side, which is less than 12, plus 6. Or in other words, 6 is less than x, which is less than 18. So I could pick numbers like 7, I could pick numbers like 11, or 15, or 17.9, or 6.3. Those could all be side lengths of my third side, but your answer is this range right here. I'll do one more with you and see if you can try the third one on your own. So we're going to subtract, and then we're going to add. So 8 minus 3 is less than x, which is less than 8, plus 3. So I get 5 is less than x, which is less than 11. All right, try the third one on your own. See if you can come up with a range of values. You should have come up with 6 is less than x, which is less than 20. All right, our last page is loading. Our smartboard's kind of being slow right now. But on this last page, you're going to have a question that you guys need to bring to class tomorrow. Answer this question on your own. We'll discuss it and go over it when we get to see you.